Okay, so this recording is for the Unit 5 lab, right? So in this lab, we are observing reaction times and seeing what effect concentration of your reactants has on this, right? So a couple of things that you'll want to grab from the course website, right? So if you're on time with getting this lab done, then you'll actually be able to grab it here off of the class plan. But if you're doing it a little bit late, it starts in 5.04. So if you go to plan, and you're looking at your calendar under month view, with the color that is chemistry, you're looking for 5.04, which is right here. Okay, this is also an assignment or a lab that you turn in discussion in instead of a lab report, although the discussion questions match the lab report questions. So if you go to 5.04, click more, and then go to the lesson introduction. That's where you're going to get materials for this. So materials are on the third page. The student guide has a couple of helpful questions in there, but the really big important thing that you want is this Chem 504 LRD reaction rate factors. It looks a little something like this. Okay, so the place to record your data, and then there's some questions that you have to answer. We'll come back to this as far as how to answer everything in here to get full points for your submission. But in addition to that piece of information from the website, there are several materials that you're going to need from your kit. So first off, I would start by getting your lab manual out, and then you're going to flip to page 43, okay, to find the beginning of the lab. So reaction rate factors, that's on page 43. Your materials list is actually on the next page, right here. All right, so a couple of things to help you as far as the setup goes. You want to find all of those materials. All right, and then something to help you save a little bit of time and also not contaminate anything. You need 3 graduated cylinders. Mark them A, B, and C, and then we're going to mark the chemicals A, B, and C too. So you only use graduated cylinder A with chemical A. All right, same thing with the pipettes. All right, you have a bag that has a whole bunch of pipettes in there. Grab 3 of them, mark them A, B, and C. And then the 4th one is actually one for water. Okay, so this will prevent contamination, having reactions happen that we don't expect to happen. So you really need to take the time to do this labeling so that you don't end up goofing something up. All right, after that, in your kits, chemical A is this giant bottle that is called potassium iodide. That's not really coming in clear on here, but potassium iodide, 0.2 molar, 400 milliliters. All right, so then I put an A on there so that I remembered this would be A. The next one is sodium thiosulfate, and I put a B on there to remember that is B. And then the last one is called ammonium persulfate. Right? This one doesn't come already liquid as aqueous, so you have to add water to this one. Okay, and you need to add 400 milliliters. So to do that, I used one of the bigger 250 milliliter beakers. I just filled it to 200 twice and poured it in. And then, you know, swirl it around until you make sure that you don't see any solids left at the bottom. Okay, and then I also have water in a beaker ready for when I need water samples or extra water with the pipettes. Then you're also going to need one of the smaller 100 milliliter beakers. This is what we're going to run all the reactions in. You're going to want a stirring rod. Okay, this comes in a pack of 3. You only need one of them. You're just going to have to wash it off in between. And you also need this starch indicator. Okay, so it looks a little bit different than the picture in the book, but it's starch indicator solution 1%. All right. So once you have all of your materials set, you have everything labeled with the different letters so that we're not going to contaminate everything. You can, in the lab report, set this up, or I just have it, I'm working on a whiteboard here, but on a separate piece of paper, some sort of table so that you know trial or mixture, okay? There's 7 that we're going to do, and you need to record times. Right? There is a stopwatch in your kit, or you can use a cell phone if you have it handy, and that's what I have handy. So I've got my handy dandy cell phone here. And because of contamination issues, I am also working right next to a sink. Okay? So you're going to have to rinse off your materials in between each trial so that we don't have any extra reactions going on that we don't want. So there's my stopwatch. Okay. So once you have all your stuff set up, you are going to be at the point of procedure, part 1, where it tells you to use this table, which is further down on the page. All right. So this table tells you that in trial 1 or mixture 1, we're going to add 20 milliliters of solution A. We're not going to add any extra water to that. All right, we're going to use 10 milliliters of solution B, and you'll notice that actually stays the same the whole way through. All right, and then we're going to use 20 milliliters of solution C, and we're not adding any water to that. Okay, so to set that one up, I need 20 milliliters of solution A. So I'm going to grab my solution A graduated cylinder, my solution A pipette, and solution A. And I'm going to get it to the point where it says 10 on the graduated cylinder, which is down here. Okay, I know you can't read that, but it's not very high on the graduated cylinder. You can pour it in there, but if you over pour, you can't put stuff back into the container. That's a no-no when it comes to working with chemicals. So if you use the pipette, kind of like in those virtual labs, grab the stuff in the pipette and then pour it into the cylinder, you'll be more likely to get the right amount. Each of these pipettes is 2 or 3 milliliters. So I'm just going to fill that up until I have 20. Oh, I'm sorry. So 20 is going to be a little bit higher on there than I said before. We're getting 20 milliliters of this. And what I'm going to do is I'm going to get everything into my graduated cylinders and just leave it sitting there. I'm not going to start mixing anything until I continue reading it through my directions. Again, if you spill anything, if you get it on yourself, rinse yourself off right away. We're almost there. If you remember with the graduated cylinder, there's not too much of a meniscus on plastic, but the bottom of the meniscus or the bottom of the curve has to be at your 20 mark. Okay, so A has been measured. I'm putting my cap back on. I'm just going to set this graduated cylinder off to the side until I have B and C prepared as well. So B, the table says 10 milliliters. Okay, so I'm filling it up to 10. That's the one that's 10. Again, I'm using the pipette, all right, to get some of my solution, and then I'm going to use the pipette to transfer it in here. It'll be a lot less likely to spill doing it this way. Might take slightly longer than pouring, but this way I'm not going to over pour. All right, I am about 3 milliliters away. There. Okay, so there's my 10 milliliters of B. I'm closing that back up. I'm going to set this stuff together off to the side and prepare C. Okay. And then just a reminder, before you can start this, you do have to add that 400 milliliters of water to C so that this becomes aqueous. You're not pouring the solid straight into your reactions. And then C, I need 20 milliliters. So I'm going up to almost the top of my graduated cylinder, or at least top of the measurements. It only measures 25. So again, using the pipette for easy non-spillage. I'm at almost 15. One more full one. And there's 20. Okay. So I'm going to set C off to the side, and this one I don't need any water in, so I don't have to worry about adding water to anything. So now we flip in the page to 46 in the lab manual. Where it tells me how to add these things to the graduated cylinder. Okay? So it says pour 10 milliliters of solution B into a clean 100 milliliter beaker. All right, then add 5 drops of starch solution. All right, so the first thing we pour in is B, and then we add starch. Then you pour the contents of cylinder A and C into the beaker. So we're going to do those as close to the same time as possible and start our stopwatch. All right, and then you stir it occasionally. When the solution turns color, stop the stopwatch. All right, record the elapsed time in the data table. Some solutions may change quickly, whereas others may take several minutes to change color. So here's the beaker that I'm going to run my reactions in. Here's my stopwatch. All right, I'm going to add my contents from graduated cylinder B. Trying to get everything out if I can. Then I'm going to add my 5 drops of starch indicator. One, two, three, 4, 5. All right, be careful to make sure that you're doing 5 each time. If you accidentally do more, start over. Because you want everything to be as controlled as possible when doing this. Now I've got A and C. I'm also showing you that I have a stirring rod handy. Okay, so I'm going to add in A and C. Start my stopwatch, and I'm going to stir. And you stir until it changes color. Yeah, the lab said some of these might happen really quickly, some of these might take a while. Doo-doo-doo. Now, something to think about is on all of these chemicals that we have, oh, there's our color change. So I'm going to stop it there. And I'm going to record in my data table. Let me scooch this out of the way so I don't spill it. .104. Took 1 minute, 4 seconds for that one to actually react. Okay? All right. So what I need to do now, and this is why I'm working near the sink, everything that was involved in the reaction, so the beaker and the stirring rod, because I don't have beakers, well, I don't have enough beakers to have 7 separate ones, nor do I have enough stirring rods. What I'm going to do is I'm going to turn the water on. Alright, you can mix this up, you can pour this down the sink, but always pour it with the water running. Alright, that way you're diluting it even more. Then I'm going to rinse out my beaker several times. Alright, I'm going to rinse off my stirring rod for a little bit, making sure that I'm getting all sides, the whole thing, anywhere that would have been in contact with the reaction. And then as one more precaution, just to make sure that there's, I'm using tap water here, so I don't want any of the dissolved solids in the tap water. I'm going to dry everything off. So there's my stirring rod, dry off the beaker, and now I can move on to part 2. Okay. All right, so part 2. I need, according to my table, I'm going to flip back to page 45, I need 15 milliliters of solution A with 5 milliliters of water. So I have graduated cylinder A, I have pipette A, and chemical A, and I'm going to fill that up to 15. Again, I'm using the pipette in the jar to get my solution A without spilling a whole bunch of it. Let's rotate this so I can see my scale. Almost there. And just a little bit more. And there's 15. Okay, so I'm going to set a pipette down, put the cap back on bottle A, and then I'm grabbing my beaker that has water. All right, ideally, you're using distilled water. If you don't have distilled water, purified would be better. Tap would be fine, but that may cause side reactions. All right, so whatever you have, use, but if you have distilled, that would be best. And what I'm going to do into that same graduated cylinder, so into A, I'm using my water pipette to add 5 milliliters of water, which means I'm going to fill it up till we hit 20 again. All right, so use the water pipette in water only. Big thing is you don't want to throw the A pipette in here because then you're going to contaminate your water. And there we go. Okay, so there's A. And then B, once again, I need 10 milliliters. So I have my B pipette. And probably a couple more. Almost there, so pour slowly. And there's my 10. Okay, setting B stuff off to the side, and I only need 10, so I'm done filling up the B graduated cylinder. Now I'm grabbing my C equipment and my C chemical, and I need 20 milliliters. Okay. So in my C graduated cylinder, I'm going to fill this up until I have 20. So it's going to take a few fills of the pipette. So while we're thinking about this, we left C alone. C should have the same concentration as before. But A, we added water to it. So we only used 15 milliliters of the straight A solution, and then we added water to it. What is that going to do to the concentration of A? Is that going to increase it, decrease it, or leave it the same? All right, based on our studies of molarity, all right, the concentration is moles divided by volume, right? If we don't add any extra A chemical in there, but we increase the water, we will decrease our concentration. So that's something you have to keep in mind as our times change. All right, we're leaving the concentration in this sample of C alone, but we decrease the concentration of A. So what do you think is going to happen time-wise? Okay, so I have my three solutions prepared. Flip back to 46, especially if you don't remember the order to add things. But I have my beaker, and I'm adding my B graduated cylinder contents. I'm adding 5 drops of starch indicator. All right, again, be careful, make sure it's 5, 2, 3, 4, and come on, 5. All right, I have my stirring rod handy. I'm going to bring my timer back up. Reset that. All right, now I'm going to add A and C. Start my timer and stir. All right, the solution turned kind of purple brown before, and we're going to keep stirring until that happens again. All right, there's no indication that there should never be a reaction, just some of these might take a while. Or maybe this one will be faster, who knows? Try not to stir differently in any round, right? Again, a control. We just want the concentrations to be what's affecting how quickly stuff happens. So if you stir really vigorously in one, you're increasing the collisions versus another one. And then maybe it's your stirring that's causing the difference. So try to stir at the same rate in each one as best you can, so that the only thing we're really changing are the concentrations of our chemicals. So it looks like this one is taking longer. If that's what you thought would happen, good job. And there's our chemical change. It turned color. I'm going to scooch this over, and we're going to record for the next one, minute 26. All right. So at this point, I'm going to let you collect the rest of the trials. All right. So if you want to use my times for 1 and 2, that's fine. Although it would be best if you did them yourself, because you may stir at a different rate than I did. Okay. But what I want to do is look at that lab report. So these 2 questions on the LRD are also what you are going to be posting answers to on your discussion. All right, so first off, you need to give me your data. All right, some of these will take a while, so don't give up before they stop. Then question 2, this is the really important one. All right, so I'm going to give you 10 points for the data and then 20 points for question 2. So it says textbooks indicate that the concentration of reactants will have an effect on reaction rate. Do you agree or disagree with this statement? So that's the first thing you need to answer. Do you agree or disagree with the statement? And that should be yes or no. What you're really going to get points on is this next part. State your case by citing data from your trial runs in the laboratory. So take specific trials from your lab that support why you agree or disagree with the statement. All right? That part right there to me is the most important part. What is the evidence from the lab that makes you agree or disagree with the fact that concentration of reactants may or may not have an effect on reaction rates? Okay? Then I want you to think critically about this. Indicate whether the results of this experiment are enough to make a general statement about reaction rates and concentration. Okay? And what we did in these 7 trials with these particular chemicals, can we generalize this to everything? Right? So, really, really, really use your data and answer this part really carefully. Right? If you don't address specific trials from your data, you will not get full credit for this. So that is my presentation. Of course, if you have questions, please feel free to contact me.